All right. Hello, everyone. I'm Sofia Eriksson, and I'm going to present to you my PhD project entitled Molecular Engineering and Green Polymer-Surfactants by SAS. The project is in collaboration with Imperial College in London and the industrial partner Procter & Gamble. So just some background, why are we studying these things? So polymers and surfactants are present in a wide range of different fields, such as pharmaceuticals, paints, and home and personal care products such as detergents, soaps, and shampoos. So the home and personal care product sector is really a multi-billion industry. It's all these products that you have at home. So for example, shampoo sales in China increased by 800% from 2000 to 2010. So this is really like, it's a big industry, and these products are just present everywhere globally. So that's why it's important to make sure that we formulate as good products as possible. And in the past few years, of course, there has been a push for more sustainable and environmentally friendly formulations. And to be able to achieve this, we need to better understand the role of each of the components in these formulations. And hopefully we can then create improved products and use lower concentrations of the active ingredients, more sustainable products, and for example, lower temperatures at usage. And so surfactants, as you might have heard of, they create these self-assembled structures called micelles. And these micelles can entrap, for example, oils or other hydrophobic substances. And this is what makes them useful in these types of cleaning products. So that's why you get rid of your dirt when you use a soap, for example. And in these kind of formulations, you also have many other components, but one of them is often a polymer. And the polymer has as a role to, for example, regulate the viscosity, but also create increase the stability of these products when you use them. So essentially, kind of as a sketch here, what you have is like you have your formulation, and you blend all of them together. You have maybe some kind of dirt that you want to remove, and we want to understand what happens here in between, basically. Why are some of the formulations more stable than others when you add, for example, a polymer into the solution or change the surfactants? And so in this project, I'm using my polymer is a bio-based polymer, so it's a cellulose derivative, which is water-soluble, HPMC, and I use a combination of two different surfactants, so a anionic surfactant SDS, which is commonly used in these types of products, and then as a co-surfactant in amphoteric surfactant DDAO, which basically is non-ionic in neutral solutions, but it can change its with pH. It can change its charge. And the methods used in this project is mainly sands, but also some sacs and some microfluidic. So we will study these systems in and out of equilibrium. So what mainly I've been working on until now is we made some nice sands experiments at the D22 at ILL. And we've looked at different solutions. So going from the left to the right, we have looked at pure SDS solutions and pure DDAO solutions at different concentrations, and then two different mixtures. So either with an excess of the SDS or an excess of the DDAO. And looked at how these solutions, what types of structures they are forming, and so on. So the main take-home message is that all of these solutions form ellipsoidal micelles. So they're a little bit elongated, as you can see. And basically, when you mix the two surfactants together, they become increasingly ellipsoidal. And also, when you increase the overall concentration, they are also growing in size. So this is some results that we have gotten so far. And for future works, we are going to look at also the mixed solutions of the surfactants and the polymer, and then trying to elucidate the role of the polymer by contrast matching, and also then continuing with the emulsification, so adding an oil or hydrocarbon to the system and look at the emulsification stability. And hopefully in the future as well, combining this with microfluidics and SANS measurements. Thank you.